Welcome back. Now this promises to be the most exciting video of this series so far. Are you ready to watch me measure stuff for 20 minutes straight? To be fair, this could actually be quite useful if you're looking at doing this yourself, and a lot of it will translate for similar engines as well. I started taking measurements of all the different shims that had been in each location prior to disassembly. I'll use these measurements when I check and adjust the valve clearances in the future. Next up was the valve spring free length. I wrote the specs down for both the inner and outer spring and started measuring with the vernier calipers. There's an argument that says that this isn't a comprehensive test of the valve springs and that the strength of their springiness should be tested to work out if they actually need replacing. But with all these things, there has to be a point in which you have to work out how much money you're prepared to throw at it. And for me, as these are all in spec as per the test in the manual, I'm going to take my chances and save on the cost of 32 new springs. Now, onto the freshly vapor blasted head. I needed to make sure that every last bit of blasting media was gone. So I employed a tip that I got from Jim at Superbike Surgery, where you stick it in warm water and blow compressed air through the passageways and bolt holes. I turned it over and made sure I covered all of it, and then I blew it all dry before leaving it to bake in the sun. I emptied the water out through a pillowcase just to see how much blasting media had actually come out. Look at that, you really don't want all that inside your engine. I gave it a wipe down, masked it and painted it, and then put it in the oven to cure. When it was dry, I took the head, a straight edge, a torch and a feeler gauge so I could check for warpage. Following the diagram in the book, I took the straight edge and placed it on the first of 9 different angles that need checking. Then I took the torch and shone light from behind to see if any seeped through underneath. Looked good, so I moved on to the next location. If any light had come through, I'd use the feeler gauge to measure how large that gap was and check it against the maximum specified in the manual. As it turned out, it was nice and flat, with no light showing through any of the angles, so I threw the feeler gauge back in the drawer with glee. Next up to inspect was the exhaust camshaft. I started with the bearing, making sure it spanned freely and there wasn't any play in any of the races. I gave the sprocket a quick visual inspection, looking for any damage or excessive wear. Moving down, I used my fingernail to check the running surfaces of the cam lobes and the journals, feeling for any scoring or notches. One of the journals had some visible lines in, but I couldn't feel them with my nail, so that didn't worry me. Then it was time to measure. I started with the outer diameter of the camshaft journals, using my 0 to 25mm micrometer. I took a measurement, made a note of it, and worked my way down the shaft. Down the shaft. Lol. Next up was the lobe height. I took note of the specs, then started measuring. I didn't actually have a micrometer for this size, so I used my vernier calipers, rotating them across the high point of the lobe, which left a reading of the lobe height. They're all fine and well within the standard range. So far, everything is checking out. Moving to the inlet camshaft, I went through the same checks as the exhaust, but I kept one eye on the manual because some of the specs are different. With both camshafts scoring full marks, I brought the valves back to the bench to measure them. First up was the valve stems themselves. Again, the inlet and exhaust are different sizes. I started with the inlet valves, putting the mic on the middle of the travel area where it meets the valve guide. .48mm. Standard is between 4.475 and 4.490, so this one checks out. Second one was good too, so I sped things up and moved down the line. Since doing this, I've learned that you should really check multiple locations on the wear area, just to check for taper, so that's something I'll do for next time. Moving to the exhaust valves now, these are a little bit slimmer. .46mm, pretty central in the standard range, big tick. With all the valve stems checked, they're all comfortably within the standard specified range. Clean sheet, guys. Well done. But that's only one side of the coin. I now need to measure their clearance in the valve guides to see if they're worn. The manual suggests the wobble method to see how much play there is by wobbling the valve in the guide. Starting with the exhaust side, I set up my dial gauge with the valve head about 10mm per out of the seat. Then I wobbled it back and forth to see the distance between those two extremes. About 0.16mm total travel, which sits towards the looser end of the standard range. I did the same on the inlet side, which was slightly tighter and well within spec. Now that I had a reference for the right amount of wobble, I worked down the rest of the head, feeling if any felt looser than those first ones. If so, I could then set up my dial gauge and check. As the exhaust guides were on the looser side, I picked up some small hole gauges so I could accurately measure the internal diameter of the guides. The ball head on the end is split and it expands as you tighten that thumb screw. Then you take a measurement of the ball head. I also picked up a stand for my micrometer, which is rather helpful to free up a hand. A hair over 4.5mm, which is just inside the standard range in the book, but well within the service limit. The spec is the same for inlet and exhaust, and knowing that the exhaust stems are slimmer, it makes sense as they're going to get a lot hotter in operation, so it allows for that expansion. With the valve guides checked, I moved on to the valve seats and faces. I'd seen a good technique using blue layout fluid, lightly marking the valve seat. So I put some assembly lube on the stem and popped it in the guide. Ooh, that's nice. Similar to a lapping technique, I gave the valve a few spins and taps. Then I took it out so I could see if there was any indication on either the valve face or the seat. To be honest, it was actually quite hard to see, so I cleaned it off and I tried a different method. As I was going to be lapping the valves anyway, I knew that I'd be able to take a good measurement of the valve seat during that process. I dabbed some fine valve grinding paste onto the face of the first inlet valve, gave it a lube, dropped it into the head, and begun the grinding process. The grinding process leaves a matte silver ring showing the contact area of the valve face, and a corresponding one on the seat. I took a measurement across the width of the valve seat. I double checked it against the valve face itself. Then I compared it to the spec in the book, and it was still within the 0.5 to 1mm range. I did the same thing with the next inlet valve, adding a small amount of grinding paste to the face, adding lube to the stem and dropping it in the guide. I've seen all sorts of fancy methods for speeding this up, like using a drill and a piece of tube on the valve stem, but personally I'm a fan of doing things by hand, especially if it's my first time doing something. You get a better feel for what's actually happening, plus I'm in no rush. You can see the technique here, where I'm spinning it a few turns, lifting it out slightly, turning it about 180 degrees or so, and then dropping it back down before spinning it back and forth again. I'm also trying my best to keep turning the valve when I'm taking it in and out of the guide, just to help it come out smoothly. There are 2 stages in the lapping process. I'm starting with the coarse paste, and then I'm going through them again with the fine stuff. I realised I hadn't shown a before and after yet, so here's 2 exhaust valves, one untouched and one that's had a lap with the coarse paste. A very important part of this is making sure you remove all traces of grinding paste from the head. As was the case with the blast media, abrasives and engine parts are not the best of friends. I also gave all the valves a decent clean to make sure they were pristine too. Then I put them back into their respective parts of the divider. I realised I probably wouldn't be happy until I'd given it another go in the bubble bath. Now I'm satisfied it's spotless, I started to refit the components. I started with the bottom valve seats, making sure they were located properly in the head. I'd picked up new valve stem seals, which are a little fiddly, but I used a hex key to drop them accurately onto the guides, and then I used a deep socket to push them on squarely. Next up were the springs. They have a right way round, which is with the tighter wound coils closest to the head. Then I lubed up and fitted the top spring seat onto the spring. And if you're screaming at the screen, I hear you. I was about this moment when I realised I should probably have put the valves in before this bit. I figured I'd probably finish the exhaust side and then I'll fit all the valves. Don't worry, that bottle of Loctite isn't the only thing holding this up. It's more of a backup in case I knock it. It was actually pretty well balanced, but this thing weighs a lot and I didn't fancy that weight on my finger. With the valves in, I carried on fitting the springs and spring seats into the inlet side. With those all in, I can hang it over the bench and fit the spring compressor. I compressed the springs just enough to reveal the collet groove in the top of the stem. Then with a bit of lube on the collet, I used a magnetic screwdriver to drop the first collet into the groove. I'd actually compressed this one more than I probably should have, which made it a little bit trickier to locate the second collet. One thing I love about having 16 of these to do is knowing I'm going to get a lot better at this by the end. I dialed it in by now. It helped to stick the tip of the screwdriver to the top of the collet rather than the side, which made it easier to drop in straight down. Then I used a plastic cable tie to jiggle it into place. I gave them a check over to make sure they were all in correctly. Then I raised the head from the bench, took a small soft face hammer and gave them all a slight knock as a final step. Next were the valve shims. I'd kept a record of their size, so I'll be able to calculate any adjustments to the valve clearances. I fitted them all along with the buckets, making sure they were coated in lube. So I'm super happy. I've measured everything and it's all in spec. I've lapped the valves and it's all squeaky clean. In the next video, I'll be checking and adjusting the valve clearances here on the bench, which should be quite straightforward. And after that, that'll be the top end done. I'll see you then.